range of a function. Objectives: domain and codomain of a function. Range of a function. Suppose the gas tank in Sriram's car holds 25 gallons of gas and the car gets 30 miles per gallon. Sriram fills up his tank with gas and heads out on a trip. His distance, or D, travelled on one tank of gas can be represented by the function d of x equals to 30x, where x is the number of gallons of gas he used. The formula would be d of x equals to 30x with 0 less than or equal to x, which is less than or equal to 25. In this function, the number of gallons used can be anywhere from 0 gallons to 25 gallons, since the tank holds 25 gallons of gas. Mathematically speaking, the number of gallons Sriram can possibly use would be the domain of the function, and the possible number of miles travelled would be the range of the function. The domain consists of the values that can be put into a function that makes sense, that is, values that don't make the function undefined. In other words, Sriram can put up to 25 gallons into his tank. It won't make sense to put 26 gallons in because one would spill out. So study about the domain of a function is very important. Let's learn more about it. Number of functions. Let x and y be two finite sets having m and n elements respectively. Then, each element of set x can be associated with any one of n elements of set y. So, total number of functions from set x to set y is n to the power m. Value of the function. If y equals to f of x is a function, then to find its values at some value of x, say x equals to a, we directly substitute x equals to a in its given rule f of x, and it is denoted by f of a. Example: if f of x equals to x squared plus 1, then f of 1 equals to 1 squared plus 1 equals to 2. F of 2 equals to 2 squared plus 1 equals to 5. F of 0 equals to 0 squared plus 1 equals to 1, etc. Domain and codomain of a function. Let f maps from a to b be a function. In general, sets A and B could be any arbitrary non-empty sets. But at this level, we would confine ourselves only to real-valued functions. That is, it would be invariably assumed that A and B are subsets of real numbers. Set A is called the domain of the function f. Set B is called the codomain of the function f. In some cases, when the domain of a function is not explicitly defined, domain would mean the set of real values of x for which f of x assumes real values. In other words, all the values of x belongs to R for which f of x is not real or not defined will not be an element of the domain. Methods for finding domain and range of function. Domain. Expression under even root, that is square root, fourth root, etc. is greater than or equals to 0. Denominator is not equal to 0. If domain of y equals to f of x and y equals to g of x are d1 and d2 respectively, then the domain of f of x plus or minus g of x or f of x multiplied by g of x is d1 intersection d2. While the domain of f of x upon g of x is d1 intersection d2 minus set of g of x equals to 0. Domain of root of f of x equals to d1 intersection set of x such that f of x is greater than or equals to 0. For example, let us consider the function f of x is equal to 1 upon 3x plus 1. Here, we observe that f of x is defined for each value of x belongs to real number set except x equals to minus 1 upon 3, the value of x at which the denominator is 0. So, domain of the given function is defined as x belongs to real number set except minus 1 upon 3. Let us take another example. F of x is equal to root over x minus 2 multiplied by x minus 3. Here, for f of x to be real, x minus 2 multiplied by x minus 3 greater than or equal to 0. For example, consider another function f of x is equal to 1 upon 8 minus 3 multiplied by sin x. We know that minus 1 less than or equal to sin x less than or equal to 1. Multiplying by 3, we get minus 3 less than or equal to 3 sin x less than or equal to 3. Adding 8, we get 5 less than or equal to 8 minus 3 multiplied by sin x less than or equal to 11. Reverse the inequality, we get 1 upon 11 less than or equal to 1 upon 8 minus 3 multiplied by sin x less than or equal to 1 upon 5. Therefore, range of the given function is equal to closed interval 1 upon 11 to 1 upon 5. Summary.